Yeah, okay. So in today's class, we'll be getting into the lecture number 6. Okay. So this lecture 6 will be dealing with the final generation of your voltage. That is nothing but your surge or a switching surge. So it will be dealing with your switching surge. So till now we have seen about the different voltage generations, starting from your high DC voltage. After that, we have dealt with your high AC voltage in power frequency, then high AC voltage in a very high frequency we have dealt, and then in the lecture 5 we have covered about your impulse voltage. So in today's lecture 6, it will be the last for your voltage segment, and it will be the starting for your current. So in this lecture, we will be what we will be seeing is that so we'll be starting with the switching surge. Okay, so we'll be seeing how the switching surge is generated. So second segment, we'll be seeing a small part of generation of your high impulse current. How the impulse current is being generated. A small introduction part will be given. Okay. So moving on, so the first is you have to know about the switching surge. What is the switching surge? So in general, so they are giving a definition for switching surge as it is a short duration transient voltage. Okay. So you might be getting some confusion between your impulse voltage and the switching voltage, switching surge. Okay. So the main difference is that in terms of a time period. Okay. If you are taking the time period into action means uh, what you can see is that with respect to your impulse voltage, they'll be giving some time period, and with respect to your switching surge, the time period would be vary. Okay, so the similar to that of your tail time and the wave tail time and the wave front time. Here also that be it will be time to front and then time to half. I'll be explaining about this the later part. So first we can get into the definition of your switching surge. So what they're saying about the switching surge? Switching surge is nothing but a short duration transient voltage. So it is a transient voltage. Normally, the transient voltage itself it will be for a very short duration. So the switching surge will be corresponding to that of a very short period. Okay. So this transient voltage, how it will be means it will be of a oscillatory wave or a damped oscillatory wave. Okay. So you might have learned about these two conditions in your what you can say in your circuit theory. Okay. So for a second order system, how the response will be either oscillatory or damped or over damped or under damped, you might have studied, right? So the same thing only here also, but it won't be of a steady state. It cannot reach a steady state. Okay? It will be of a oscillatory segment. So here they are giving the frequency. So in general, we might have generated in the previous lecture a high AC voltage for your power frequency as well as a very high frequency. And for switching surge, they are giving the frequency ranges 100 hertz to 100 kilohertz. Okay, so this is the frequency range for your switching surge. Okay, so if it is 100 hertz to 100 kilohertz means it will, you can also find the what you can say you can find the time period. Okay, so it will be 1 by 100 seconds to 1 by 100 into 10 power 3 seconds. Okay, so that's the duration at which your switching surge is possible. Okay, so why the switching surge occurs and what is the main reason for the occurrence of the switching surge? So the main reason of the switching surge is that it might be occur due to the opening or closing of a switch, okay, or a circuit breaker due to an arcing fault. So this switching surges where you can generally expect in real time means you can expect at your substations. Okay, so for the substation, In case any kind of a fault occur means, what they'll be doing is generally they will be isolating the segment. They will be isolating the faulty portion alone separately. Okay. So in order to isolate such a faulty portion separately, what they will be doing is they will be switching on or switching off the corresponding circuit breakers. Okay, I'll be showing a video also for this, and you can understand about it. Okay, and similar to that of your impulse voltage, what we have described through Indian standards, here also they are making through some standards. So mainly these Indian standards will be following the IEC standards. So IEC standards are the standards which are being framed by the European Union or the British, okay, or the England. But if you're getting into the IEEE standards, means IEEE standards will be normally framed by the US or America. Okay. So what they're saying as per the IEC standards, so the surge switching surge will be from 250 to, that is 250 to 2500 microseconds. Okay. And here they are giving the tolerance value also. So for the time to front, the tolerance value will be 250 plus or minus 50 microseconds. Okay. So and for the other part it is, that is time to half hour, it is 2500 to plus or minus 500 microseconds. So these are the two things. And the main method, okay, the main method for generation of the switching surges, and yeah. So these are the two methods. So the impulse generator circuit modified to give long duration wave shape. Okay, so similar to that, so how the switching surges is possible means, so in the generation of the impulse generator circuit we have seen, so the normal RC circuit we have seen. So that RC circuit with the wave shaper will be designed for a longer duration. So for that, what they will be doing is that they'll be increasing the time constant value. Time constant for the RC circuit is nothing but tau equal to RC. So they will be increasing either the value of resistance or the value of your capacitance. They will be increasing. Okay. So the next method is that power transformers or testing transformers excited by DC voltages. Okay, giving oscillatory waves, and these include Tesla coils. Okay. So using the power transformer, so this concept I'll be showing in the video how they will be generating with the through the power transformers. Generally, in the power transformers during the time of switching. So at the substation, you can see about your CT and PTs. Okay, there will be current transformer as well as your potential transformer. Okay, while switching through the circuit breakers, there you can see the switching surge. So while I'm showing the video, you might be getting a clear idea. Okay. So how using the impulse generator you can create the switching surge here they have given. So it is the same similar principle what we have seen in your previous lecture. So through your impulse generator RC circuit, you have generated your, so this first diagram corresponds to your normal impulse generator wave. Okay. So second corresponds to your switching surge wave. Okay. So here that's only they are saying the values of R1 and R2 for producing 100 to 100 microsecond wave shapes will be ranging from 1 to 5 kilo ohm. So here they are giving a predefined value. As I said, this will be depending upon your time constant tau. So your time constant tau will be directly proportional to your R and C value. So here what they're doing is they are increasing the value of your resistance. Okay. So here a small modification is made. Okay. So R2 they are bringing inside. So the position is varied for your switching surge circuit. So the main limitation over this kind of generation is that the efficiency decreases. Okay. because upon increasing your resistance, generally there will be more amount of heat dissipation, okay, in the resistors. So which might be getting to some kind of losses. Okay. So this is the second thing using your transformer. So this is a simple format. So what they are doing is that they'll be making use of a spark gap. Okay, so this is your supply side, and this is your load side, and that is a voltage or output you can get it out. So what happens is that the input will be given here and it will be charged. This spark gap, or they might be saying about the spear gap, and through the spear gap, it is possible to extract the voltage. Okay. So next topic is that okay. Before getting into this, I'll be showing you about the switching surge. Okay, then you might be having some more idea. So here you can see I have another video. Okay, so through this video you can get some idea. Okay, so here you can see. So they are just switching out they're making some switching action over here. Okay, when it is getting open, so here the surge like spark has been or arc has been formed. Here you can see. So it is just keep on increasing. So this is possible how means the particles are getting ionized. Okay, so the arc is uh, visible to you. Why this is means the uh, particles, that is ions over the surrounding area will be ionized, and it will be possible for you to form the arc. Here also you can see. So they are making the switching action. Okay, while they're making the switching action, there's a formation of some surge. You can see it clearly. So this is what your switching surge is. So again, here also you can see. This is another one. So these are nothing but your transformers only, CTPTs, which are in the substation. Okay. There you can see a surge. So before getting, that is closing also, the formation of surge is possible, not during the open condition alone. So here also it is a closing action. There you can see the surge. So mainly you can see these kind of things at your substation only. So here it is the opening action.
Perfeito vídeo.
Here it is the opening action. That's it. So these are some of the examples for your switching surge. So now we have completed switching surge. Next we'll be moving to your impulse current. So how the impulse current is generated. So till now we have seen about your voltages segment. So your voltages part has been over. So your current segment is a very small part because your current will be more or less similar to the generation of your that is your voltage part only. Okay? So here you can see how the impulse current will be generated. Before that, I will be giving an intro to your impulse current. So what is the impulse current? Okay. So here they have given for the generation. Okay, before that they have to know about the impulse current. Okay, so this is what your impulse current waveform characteristic waveform looks like. Okay, so that is what happens is that here you can see similar to the impulse voltage waveform. Here you can see the time periods are predefined. Okay, so here from T1 and T2. Okay, so T11. Okay, here represents T11 and T12. This represents your time to front of waves 1 and waves 2. So here they have given two waves. Okay, wave 1 and wave 2. So your T11 and T12 will be your time to front wave, and time to tail wave will be your T21 and your T22. Okay, as I said, there will be possibility for two forms. One is your damped oscillatory wave. So your first one is your damped oscillatory wave. See here you can see your oscillation, and the second one corresponds to your overdamped wave. Okay, okay. So this is how your characteristics looks like, and this characteristics waveform alone they have asked more times in your university exam. You can expect this question, this separate A as a question you can expect. Okay. What is the impulse current and how it can be produced if you are taking into account means for producing impulse current or a large value, a bank of capacitors connected in parallel are charged to a specified value and are discharged through a series RL circuit. Okay, so this is a simple concept. So for what do you say, for not to generate a very high impulse current, what they'll be doing is they'll be charging a capacitor, okay, and they'll be discharging it through a inductor and a resistor. Okay, this is a simple concept. But what you have to get into, what you have to know is that you have to know about the time period. So when you can say it is an impulse current waveform means as per the time period. Okay, the wave shapes of impulse current using testing surge derivatives are here they have given the time period. So 4 by 10 this corresponds to the first 4 corresponds to the wave front time, and your second 10 corresponds to your wave tail time. Okay. Here they are giving the tolerances plus or minus 10%. So they are analyzing the circuit. It is nothing but a series. This is a series RLC circuit. Okay. So the same analysis will be given. So they will be applying KVL. Okay. They will be applying KVL and they will be finding again the roots of the equation. So the roots will be corresponds to alpha equal to r by 2l, omega equal to root of 1 by LC minus r square by 4l square. So this same expression you have studied in your circuit theory. Okay. In your unit 4 you have studied. Okay. The same thing is repeating over here. So here they have defining the time periods. What is your T1 corresponds to, what is your T2 corresponds to, here they are defining. Okay. So this expression you don't need to worry. I will be giving in your notes. Okay. The notes will be put on over at your Google Classroom within today or tomorrow. I will be putting your notes. So in that notes you will be getting a clear cut idea. Okay. So you can see through that. And in this, the possible question, what you can expect is that you can expect for your the methods of generation of your switching charge you can expect. The second thing is the important question, what you can expect is the characteristic curve of your impulse current waveform. So many of you will be, what mistake you will be doing is that you will be drawing the impulse current waveform, but the axis what you will be doing is you will be marking wrongly. So in your x-axis only the time period. So in the impulse voltage waveform also the same thing, but at the impulse at the y-axis you will be marking with your current. Okay. So this is what the lecture is about, and you again, if possible, you again see the video what I have posted also. You might be getting some more idea regarding that. Okay. So I think this we can end up today's lecture.